All right, so if you take a look at the worksheet, and if you don't have it printed out, that's okay, because I've got it up on the board. Under this topic 3 of does an equation represent a function, I've actually got 8 problems. They didn't all fit conveniently on the board with me leaving room to work things out. So I've just written out the first 4 here. What I'd like you to do is pause the video and try to work those out, and then tune back in and we'll work through those together. If you want to, if you already have the worksheet printed out, or if you look it up on the computer, if you want to work through all 8 problems, that's totally fine, because of course once I've gone over these, I'll write down the next 4 on the board and we'll go through those. So right now, pause the video, work through at least these 4 problems. If you feel like you're on a roll and you want to just work through all 8 of the problems, that's totally fine, because that's what we're going to do right after this. Okay, hopefully that went fairly quickly, because at least these first 3 should be pretty quick. These first 2, we've got y by itself equals some formula involving x. Yes, that's a function. Y by itself equals some formula involving x. Yes, that's a function. Notice it's perfectly fine to have even powers of x. It's even powers of y that cause a problem. Okay, if I know what x is, let's say x is 5, well then x squared is 5 squared. It would be 25. That's a unique answer. If x was negative 5, x squared would be negative 5 squared. Notice I'm squaring the whole thing, the negative sign as well as the 5. That would also be 25. That's a unique answer. Now there are 2 different x values that give me that answer, but for each x value there's a correct answer. Okay, so these 2 are functions. This one, the even power is attached to a y, so that is not a function. That's the shortcut. If we want to remind ourselves of why it's not a function, we could try to solve for y. Now it's not necessary to do that. The answer to the question is no, and you can just write no. But let's remind ourselves. Y squared equals x. If I took the square root of both sides, I would get the absolute value of y equals root x. So y would be plus or minus root x, because there are always 2 values that have any given absolute value. Okay, so that having 2 options is why this is not a function. Now, number 4 is the one that's a little bit different from what we talked about in the last video. Notice that's an odd power. So if I start with x equals y cubed, if I want to try to get y by itself, I would try to undo what I was doing to y. So I'd try to take the cube root of both sides. Now the cube root of y cubed, and in fact the odd, if I'm working with odd numbers, the nth root of the nth power, as long as n is odd, is just going to be y. So the cube root of x is equal to y. I've got y by itself equals some formula involving x. The reason that that's different is because if I'm working with even powers, when I take a negative number to an even power, I get a positive result. I lose the information about the sign. But if I'm working with odd powers, for example, if I look at negative 2, let's say y was equal to negative 2, y cubed would be negative 2 cubed. That's negative 8. I don't lose the information about the sign. Okay, so odd powers, I can undo them perfectly by taking an odd root. But even powers can't be undone perfectly, because when I try to undo an even power by taking an even root, I don't get the variable I started with, I get its absolute value. Okay, so this one was a yes. All right, next part of the video, we'll work through problems 5 through 8. If you've already done that, fantastic. Just fast forward through the part where I've got them written down on the board, and we'll go through the answers together. Okay, I've got problems 5 through 8 written down on the board here, just in case you didn't have a printout of the worksheet. What I want you to do is pause the video, try to work these out, and then tune back in and we'll compare answers and check your work. So if I look at question number 5, I see an even power of y. I'm immediately going to say no. In this case, if I wanted to, I could do some work to remind myself of why this is not going to be a function. Not necessary, but certainly not wrong to do. This would be y squared equals 5 minus x cubed. I could take the square root of both sides, but that would give me the absolute value of y equals root 5 minus x cubed. So y, I would have two options. It would be plus or minus root 5 minus x cubed. Okay, if I look at this next one, I see an odd power of y. So I'm pretty sure that one's going to be a function, but let's just confirm it by showing that we can in fact get y by itself. So I've got x cubed plus y cubed equals 5. I'm going to subtract over that x cubed again. So y cubed is 5 minus x cubed. Cube root of y cubed is the cube root of 5 minus x cubed. Odd powers and odd roots undo each other perfectly. So this is just y equaling the cube root of 5 minus x cubed. All right, wrote that a little funny. There we go. Okay, so I am able to get y by itself equals some formula involving x. So yes, this is a function. If I take a look at number 7, I've got y by itself involving some formula equaling some formula just involving x. So yes, that's a function. I do want to be suspicious of absolute values though when they're around the y. Because when we were taking the square root of y squared and we were getting the absolute value of y, we saw, oh wait, there are two numbers that have the same any given absolute value, at least if it's a positive number. And so that was what gave us options. So if x is equal to the absolute value of y, that's going to mean that y is plus or minus x. Now in this case, there are some restrictions on what the domain can be. If x was a negative number, there would be no value of y that would work that way because absolute value isn't negative. But let's just say x was 2. Well, 2 is the absolute value of both 2 and negative 2. So there would be two y values I would associate with that positive number. Okay. So the absolute value does put some restrictions on the domain. X, since it's equal to the absolute value of something, can't be a negative number. But if x is in the domain, and if it's a positive number, there are going to be two y's that go with that. So the answer is no, this one is not a function.